So you have a client, you are an engineer, so what do you do? Well, first of all, you look at the user requirements, you look at the need, and broadly speaking, the need of the client can be uh, basically split into two types of, let's say, entities. So one is information, the other is energy. So if you think about it, almost everything that electrical engineers, electrical electronic engineers do is has to do with energy or information, or a combination of the two. So in information we can gather, store, process, transport, and present it. In energy, the same, we can distribute, store, convert, and also generate the various forms of energy. Very interesting distinguishing, just an observation that you can distinguish between them. In the old days, we used to call this processing of information cybernetics, but it's an older word, not used so much anymore. Okay, let's look at the engineering definition and also the definition of design, commonly used definitions. So engineering is the innovative action of turning theoretical ideas into physical representations of either products or systems. The key word here is innovative action or innovation, something that is new, novel, and hasn't been done before. Same thing with the design, it's also innovative or inventive. It is now, in this case, not just only turning it into physical representations, but products. So when we talk about in design, we are actually looking at products as our end product or end goal that we have in mind. So design process, we've got 4 or 5 different steps, the commonly recognized, you can see over there, where we have our reference. First of all, we have a definition, then we gather information, and then we synthesize. So this is the analysis phase. Then we've got the synthesize phase, which is producing the solutions and then choosing solutions. So it's examining and selection, and then testing and implementation. Like that. So alright, so what we have then is the analysis phase, and then the synthesis phase. So analysis would mean pull something apart, and synthesis means put something together. So this is what we do. We analyze, in other words, we pull the problem apart, and then we synthesize a solution by putting different components together to form a solution for us. So we'll do usually in design process, we'll do several, maybe 2 or 3 or so at the minimum, and then we compare and choose the best and then optimize. So there you go, this is a definition of the problem, information gathering, which is analysis, generating multiple solutions, that's synthesis, and then analyze and select the best solution. So then you take that one, optimize it, and build it and test it. That's more or less the design process. Now engineers have tools nowadays that we didn't have 30, 40 years ago, and these tools are called computers. They are everywhere, they're mobile, they're in our pockets, on our desktops. They're pretty powerful nowadays. So computing power is cheap, and what we can do is simulate. So rather than build physical circuits, we can simply simulate, meaning press play and it will run as if it was in the real world, but it isn't. And then you can circumvent many errors. Some of them can be costly, so there's in terms of money, but also in terms of danger. So when you simulate dangerous systems and circuits, it's much better than trying to build it and maybe something catastrophic goes wrong. Okay, and then just some remarks on why simulations are a good thing. So we just mentioned danger, inexpensive, and some other reasons you can read there on the bullets. Alright, so we are looking now at product development. That first part, the 5-step process, was for design. Now look at product development, so specific focus now on products. Phase 1 is where we take our concept, we make a concept of the product, then we look at, is this thing at all technically feasible, Then we develop. Now this is the bulk of the activity will take place over there. And then after this we will do production, which would be pre-prototypes, prototypes. So we call this production preparation. Then after this we'll scale production, and then after this we've got support because the products have already been sold.